Last episode, the model handed us a clean probability distribution over every possible next token. Now the question is simple and consequential. How do we pick one? That single choice decides whether your model sounds like a robot or a writer. Meet the sampler controls. Picking the single most likely token every time is called greedy decoding. It is precise and fully deterministic, and often dull and repetitive, looping on safe phrases. So we add controlled randomness. The dial that controls it is temperature. Temperature reshapes the distribution before we sample. Below 1, it sharpens. The top token gets even more likely. The model plays it safe. Above 1, it flattens. Long short tokens get a real chance. The model gets adventurous. At 0, it collapses back to greedy. Same model, completely different voice. But you usually do not want to sample from the entire vocabulary. Most of it is nonsense for the current context. So we cut the field. Top K keeps the K most likely tokens, a fixed size shortlist. Top P, also called nucleus, keeps the smallest set of tokens whose probabilities add up to P. So the shortlist grows when the model is unsure and shrinks when it is confident. 2 more knobs and a rule of thumb: repetition and frequency. Penalties downweight tokens the model has already used to stop loops. And the big picture rule, greedy and beam search exploit. Great for translation and closed answers. Temperature, top K and top AP explore. Great for open-ended chat. Exploit for one right answer. Explore for many good ones. Let's make temperature visceral. Same logits, same prompt, 3 settings. At temperature 1/3, watch the distribution spike. Almost all the mass jumps onto Paris. Conservative, nearly deterministic. This is what you want for facts. At temperature 1, the natural shape, Paris leads, but real alternatives keep some probability, balanced. At temperature 1.5, the bars flatten, the long shots rise, and a surprising token can win the draw. Creative and riskier. Great for brainstorming, dangerous for a tax answer. And here is the candidate set. With top P at 0.9, we keep just the few tokens that together cover 90% of the probability, the shaded nucleus, and ignore the long tail. Every one of these dials is a request parameter on vLLM, TensorRT-LLM, and NIM, temperature, top P, top K. So this figure is your production API. We have controlled one model. Next, what happens when you make the model itself bigger? Scaling loss. See you there. Thanks for watching. Like and subscribe for more videos like this, and I'll see you in the next one.